Hello friends, welcome to engineering tutorial. In today's video we are going to discuss about another temperature sensor. In my previous video I discussed about RTD, resistance temperature detector, as a temperature sensor. So in today's video we are going to discuss about thermistor as a temperature sensor, which will be used for measurement of temperature of an object or entity or surroundings. So let's get started. So what is a thermistor? So a thermistor is basically a semiconductor device which is used for measurement of temperature of objects or entities. Okay, so the thermistor, the word thermistor actually means thermally sensitive resistors. Okay, that's what thermistor actually means, thermally sensitive resistors. So they are sensitive or responsive to temperatures. So the thermistors are actually made of sintered ceramics. Usually the mixture consists of oxides of iron, manganese, nickel, cobalt and copper. So the operating principle here is that the thermistors have negative temperature coefficient of resistance. It means that the resistance of the thermistor is inversely proportional to the temperature of the object or the surroundings in which the thermistor is installed for the measurement purpose. So note here that RTDs have positive temperature coefficient of resistance. Okay, means the resistance of RTD is directly proportional to temperature, but here in thermistor it is the opposite. They have negative temperature coefficient, which means that the resistance of thermistor is inversely proportional to temperature. So when there is an increase in temperature, there is a decrease in resistance. When there is a decrease in temperature, there is an increase in resistance. Okay, opposite behavior. So that's the main operating principle which is utilized for measurement of temperature using thermistor. Then is the design of thermistor. Now the thermistor generally comes in three common design configurations. First is the rod type thermistor. So basically it is in the form of a rod with connecting leads. Then the second one is the disc type thermistor. So it's in the form of a circular disc with connecting leads. And the third configuration is the bead type thermistor, okay, in the form of a small medicine tablet or capsule with a small bead at the top with connecting leads. Now thermistor is actually also a passive transducer. It means that it requires an external voltage supply. It is not self-generating. It cannot produce its own voltage or electric potential. It has to be connected to an external voltage source, and then to convert the change in resistance into voltage or current, we have to use a signal conditioning circuit. As resistance is involved, here also same as RTD, will be using Wheatstone bridge and voltage divider circuit, which we are going to discuss in the upcoming slides. So now there is a relationship which governs the temperature of the thermistor and the surrounding temperature of the object or the entity whose temperature is to be measured. Okay, so the resistance of the thermistor R subscript T at a particular temperature T is given by R subscript T is equal to A into e to the power B by T. Here A and B are constants which depend on the material which is used for the fabrication of thermistor. Okay, so there is an exponential behavior here. Okay, so R subscript T is equal to A into e to the power B by T. A and B are constants which depend on the material which is used for the fabrication of thermistor. Now, when two temperatures T1 and T2 are involved, we can write the resistance of the thermistor at these two temperatures T1 and T2 as R subscript T1 by R subscript T2 is equal to e to the power b into 1 by T1 minus 1 by T2. So, these are the mathematical expressions which govern the relationship between thermistor output resistance and the surrounding temperature. Now, the relationship between the constants A and B can be expressed as A is equal to 1 by R subscript T into the derivative of the thermistor resistance with respect to the temperature, which is given by A is equal to minus B by T square. Now, please note down these expressions, it will help you for understanding it in a better way. So, these are the relationship between the constants of the thermistor A and B, which depend on the type of material which is used for the fabrication of thermistors. So, here it is the reciprocal of thermistor resistance multiplied with the thermistor resistance, which is differentiated with respect to the surrounding temperature. Okay? Thermistor reciprocal of thermistor resistance multiplied with the differentiation of the thermistor resistance with respect to temperature, which is simplified as A is equal to minus B by T square. You can cross check. So, now comes the signal conditioning part. Now, as there is a change in resistance in thermistors, so obviously we have two choices, either to use a Wheatstone bridge or voltage divider configuration. We have used both of them. Okay. So, similar to RTD, which I discussed in the RTD video, the thermistor is connected in one of the arms of the Wheatstone bridge. So, there are 4 arms, one of the arms constitute the thermistor and it is treated as a resistance. It is calibrated at a specific temperature, which is called as the reference temperature, at which the galvanometer shows no deflection. Okay. Whenever there is a change in the temperature from the reference temperature, so the surrounding temperature varies from the reference temperature or the calibrated temperature, there is a change in the resistance of the thermistor, which results in the unbalance of the Wheatstone bridge. As a result of that, current flows in the circuit, which results in the deflection of the pointer of the galvanometer, which indicates that there is a change in the resistance. And in the voltage divider configuration, the thermistor is connected in one of the arms of the voltage divider circuit, and the output voltage is taken across that arm only. So, the output voltage is directly related with the change in resistance of the thermistor, which is dependent on the surrounding temperature. So, whenever there is a change in the temperature of the environment in which the thermistor is installed, the resistance of the thermistor changes and the output voltage also changes accordingly. So, these are the two basic configurations of signal conditioning which is used in case of thermistor. The same is used for RTD, resistance temperature detector. You can check out that video in my YouTube channel. So, here I have discussed about the design configuration, operating principle, mathematical relationship and the signal conditioning concepts related to thermistor, which is used as a temperature sensor. So, in my upcoming videos, I will be posting a lot of videos related to sensors and transducers. So, please subscribe my channel Engineering Tutorial for more such videos related to electrical, electronics and instrumentation engineering. Have a great day. Thank you very much.